Hey guys, this is Ms. Katz, and today I'm going to take a few minutes to go over the Unit 3 study guide for my advanced class. So we're going to just get right into it. The first question says, what is the name of a number that multiplies a variable, such as the 9 in the term 9x? That is a coefficient. Okay, the number that is paired with the variable, we assume multiplication. Remember, if we don't see an operational sign, so there's nothing here to tell us what to do with this, we assume multiplication. So this means 9 times x. And whatever number is being multiplied by your variable, we call that the coefficient. All right, when it says evaluate in question number 2, it means get an actual numeric value for that. And in this case, we're going to use the order of operations to do that. So we start with the order of operations. The first thing we work on is the parentheses. So we're going to work within the parentheses first. And then we are going to work inside the parentheses, we're going to work in order of operations. So in the parentheses, I have my choice of exponents, subtraction, or division. We know that exponents come first. So I'm literally going to leave everything else alone, but I'm going to evaluate those exponents. And if you notice, 27, 6 squared means 6 times 6, which is 36. Then we look at what we have remaining, and we've got division or subtraction. Well, division comes before subtraction. So this becomes 36 minus 2. Notice everything else is staying the same. We're still working in the parentheses. This becomes 34, and we're going to add 27 to that. And when we do that, we get 61. That is your final answer. Question number 3 asks us to write in exponential form. That means write that expression using an exponent. Well, there are 7s here, and there are 5 of them. So this is 7 to the 5th power, because remember, 7 is the base. It represents the number that's being multiplied, repeatedly multiplied. And 5 tells us, that's the exponent, it tells us how many times we repeat 7 as a factor. Okay? Sorry, I'm just going to look over here real quick. And now we're at number 4. I'm sorry. We're going to evaluate if the value of n is equal to 7. So what that means is wherever you see the letter n, we are going to replace that with the number 7. So the first step in this every time is to write it out with the replacements. We call that substitution. So the first step, all I am doing is substituting in 7 wherever I see an n. Okay? And when you do that, then we have to apply the order of operations, and exponents are going to come first. So this becomes 3 times 49, because 7 times 7 is what 7 squared means, plus 4 times 7 minus 7. So here I'm going to take that 49 and multiply it times 3. That's 147. So it's 147 plus 4 times 7 minus 7. Notice each time I am changing one thing. So this is 147 plus 28 minus 7. And 147 plus 28 is 175. And we still have to take away the 7. So we have 168 being our final answer. Okay. Question number 5 says to write an expression that represents 12 more than a number. Remember, in order for it to be 12 more than a number, we have to start with that number. So we start with n, and we're going to add 12 to it. That way it is 12 more than whatever we started with. Question number 6 asks us to simplify the expression, combining like terms. So remember, what I did was I took each term, so this is n to the first power. We're going to look for all the n's to the first power, and we're going to take their signs with them. So we know if we're adding or subtracting. Okay? All of these are like terms because they all have the same variable to the same power. Then we're going to identify the next term. In this case, it's n squared. So again, we're going to grab all of those, and then we're going to combine them. This means 7n plus 13n, which is 20n. 20n minus 1n is 19n. And 19n plus 17n's is going to be 36n's. And then if we look at your n squared terms, 15n squareds minus 14n squareds will leave us with 1n squared, and we typically write that just as n squared. Now, we talked about in class how the standard format for writing an expression like this has us using our variables in alphabetical order. Here that doesn't really make a difference because all of our variables are n. And then we actually we write them in order of the highest exponent to the lowest. So that's why I rearranged the order. At this point in the game, I'm not going to count it wrong if you don't have them in the correct order, but it is a good habit to get into, as that is going to be something that you need to be able to do going forward. So that's what I would recommend. All right, question number 7. The cost of seeing a movie is $8.25 for admission, plus an additional $2.25 for each snack. Write an expression to represent the cost of seeing a movie and purchasing snacks. All right, well, when you walk into the movie theater, automatically you're going to pay $8.25 right off the bat. Then if you buy snacks or if you don't, there's going to be a cost. So it's going to be $2.25 times the number of snacks you purchase. Notice if I purchase 0 snacks, it's only going to cost me $8.25 to go to the movies. If I purchase 1 snack, it will be $8.25 plus the $2.25. If I buy 2, it increases from there. That is the expression that we can use to find out the cost of a movie, no matter how many snacks we decide to purchase. All right, question number 8 says, which expression is not equivalent to the others? Well, let's actually evaluate each expression and see what we get. This particular one, we're going to use the distributive property. You don't have to, you could use order of operations, but I want you to see that this is the mama bird right out here, and here are her babies. And 7 times 6 plus 7 times 9 is the same as this one. So we know we're on the right track. This gives me 42 plus 63. So look, this expression here is equivalent to this one and to this one, which means that this expression right here is probably going to be, it's not equivalent to this one. Let's work that out. We're going to actually get 105. So this is 105. When you add this, you're going to get 105. When you multiply 15 times 7, you're going to get 105. Now, the reason this one looks so close, I even almost fell for it. But look at the difference here. This is 7 times 6 plus 7 times 9. This one is 7 times 6 times 7 times 9. That's going to give you something entirely different. So the answer to this question is D. It is the only one that is not equivalent to the other ones. All right, and then the last problem also asks you to apply that distributive property, so we're going to do that. 12 is your mama bird, and sitting in her nest are the 2 babies that she needs to feed them. And remember that we feed the baby birds through multiplication. So this will be 12 times 17x plus 12 times 19. I don't know 12 times 17 or 12 times 19, so I'm going to take it off to the side and do that. 12 times 17 is done like this. That's 204, 204x plus 12 times 19 228. And that will be our final expression. We cannot combine these anymore because they're not like terms. They do not have the same variable to the same power. All right, that was the first half of the answer key. I'll come back with a second video on the second half.